This is an ongoing series provided by RepublicNetworks.com, and we're going to continue with our series on hubs, switches, routers, and firewalls. This is an overview light, which means we're not going to be able to cover all details. It's more or less a general overview on some information describing the characteristics of some of these network-connected devices. We do recommend you view the first part of these module series because the information does build. This is part 4. We're going to be specifically talking about routers. This is part 4, and it really hits some of the most important network-connected devices, and in particular, their network routers. As you can see here, like we said in the first modules, the basic functionality, the basic job of a network router is to connect two different types of networks. And when we talk about type, as we go on with the IP addressing scheme module and some more network information on OSI models, we'll explain that in other modules. But the basics is typically networks can consist of IP addresses, as you'll see here. A 192.168.0.1, that is a privately assigned IP address. And then we have other networks which are based off public assigned IP addresses. This is a made-up number. I have no idea where it goes, so have fun trying to figure out what that one is. But the bottom line is that's the basic functionality of a network router, to connect one or more networks together and to provide pathing and routing, similar to a network switch. But a switch works on the layer 2, which is MAC address. The MAC address basically is the ID locally, but really an IP address is how really ultimately networks are defined. While all these machines, in this case workstations, have a MAC address, they also have an IP address. And there is a procedure which we'll explain in another module that links IP addresses to MAC addresses. But really network routing is primarily done on an IP basis opposed to a MAC address basis. Basically, as you can see in the example here, this is just some basic information. There is some information omitted for the sake of this conversation. Basically, this would be your local network, your local LAN, local area network. These 3 workstations will be located. They're connected ultimately by a switch. But as you notice, we're not really dealing with the switch ports as we did before, so don't worry about that. The biggest things to understand is, as you notice, there's 2 connections, and it really doesn't show that great in this graphic, but there's 2 physical cable connections. In this case, they're both Ethernet, just to make this conversation easy. As far as the router, it sees those informations, just for the sake of this conversation, as other terms, but we're going to call them interface 1 and interface 2. This little box here designates the network routing table, basically. And what it does is, this is what's inside the router. So when you have your router connected to 2 separate networks, in this case, a 192.168.0.0 network, .1 is the IP address for the router. So once again, the network ID is 192.168.0.0. That is a network identification that identifies the network. It's going from 1 to 255, which we'll explain in the IP addressing module later. It goes from 1 to 255. You can't use 0, and you can't use 255, so you have 1 through 254 IP addresses. So for every local area network, you can assign the devices, as you can see here. This one's 2, this one's 3, this one's 4. You can assign up to 254 addresses, theoretically, although we don't necessarily recommend that, when it comes to a network, without going to another network IP address. And we'll explain how that kind of works later, but once again, this is a general overview, and it's a light version. But basically, as you can see, your local area network is defined by this network, 192.168.0.0, and each device has its own unique IP address, which is similar to a social security number. It's unique to every device, and as you can see, this is .1, .2, .3, and .4. So each one of these, like you have your own social or another ID, depending if you're viewing this from another country, every one of these devices has an individual specific ID that identifies it on the network. So when network data comes in, it knows it has a destination of one of these IP addresses or another. The key function of a router not only is establishing the network that your local area has, but also connecting you with your external network, which in this case is the internet. Now, keep in mind, the internet also has provided an IP address, once again because this router has 2 interfaces. The computer has 1 interface, so it has 1 IP address. The router has 2, in this case it can have many more, but in this example it has 2 interfaces. They're both Ethernet connections. One connects to your local area network and one connects to your internet connection.
The IP address that's provided here, the 192.168.0.1, is something you define as a network administrator. The 72.72.72, which once again that's an example of an ISP, Internet Service Provider, provided IP address. They actually give you this IP address. Whether static, it's one particular address, or dynamic, it's an IP address that's assigned to you out of a pool of available IP addresses, which means your IP address may change. 72, 73, whatever it may be, it's all dependent. So basically that's how the router distinguishes between networks. You notice we did mention basic static routing mode of a router, which would be considered network address translation. Basically, as far as the outside world, from your router to the internet, as far as the whole outside world is concerned, this IP address, your public IP address, represents your entire internal network. When devices communicate out, they communicate out from this IP address. So if these computers talk to a website, the website sees this address, the external address, because the router is doing a network address translation. It never sees with the network address translation in a standard mode, it never sees your internal IP addressing. This is a very important concept to understand, that when these computers talk, the router replaces their IP address with its external IP address and then continues on with that communication. So once again, as far as the world is concerned, it only sees this one external address, and it basically shields or hides your entire network, which is a nice one-way firewall, but it's very basic, it's very rudimentary, and it's easily defeated. We'll talk about that in a later module. So basically, how do these computers know how to get out? Well, in addition to IP address, subnet mask, which identifies the IP address and how the structure is built, it has something called a default gateway. And the long story and short of it is, a default gateway is in these computers, it's programmed, and so these computers know that if they're looking for information that's not available on their local area network, inside your local network, it will go to the default gateway, which is its connection to the outside world to request data that's not available locally. So for instance, if you're trying to request yahoo.com or Google or whatever, obviously that's not hosted on your internal network. It uses what they call a DNS server, we'll talk about that in another module, to request information out of your network, and it queries the IP address for google.com. So that's actually a port 53, and that's a DNS entry. So when you request an internet page, which is a name, a DNS name, it goes out to the internet and says, hey, what's the IP address of the Google server? The internet replies with an IP address back to the computer, and then the computer then subsequently connects to that IP address the domain name server has provided, and then provides the web page and data that you've requested. So we'll talk about that in another process, but basically that is a general process on how these computers talk through a switch, then subsequently through the router, and then process through the router and to the internet, or your destination, wherever that may be, whether it's the internet or another private network. There may be a network just like this on the other side that you're trying to communicate with. So the importance is, once again, two interfaces, they're connected to two networks. The router knows there's two networks, and it provides